So basically, I lead some of our research on the impact of long-term technology trends. AI, robotics, automation is one of our major research themes at the McKinsey Global Institute, which has been part of McKinsey for a quarter century now. And so I'm going to talk a little bit about what we've been doing, partly with, we're about to go to a coffee break. So this is meant to be provocative a little bit in terms of some of the things that you might talk about during coffee break with the other people in the room. So first of all, who's worried about Skynet? Sorry, not a Star Wars reference, another movie? All right, fine. I'm not going to talk about that. Who's worried about inequality? Come on, you're in San Francisco. Look around outside. I mean, seriously, look around outside. And who's worried about jobs? Maybe? All right. Let me motivate the conversation a little bit. If you look over the past 50 years at the largest economies in the world, call it the G19 plus Nigeria. By the way, I didn't know this until we started doing research. The G20 actually includes the EU, which is strangely referential. Anyway, so the G19 plus Nigeria. For the past 50 years, cumulative average growth, annual growth rate of the economies, roughly 3.5%. About half of that economic growth came from increases in the labor force. More people, greater population, more women in the workforce. Again, should be more women in tech as well, but more women in the workforce. And about half of our economic growth in the largest economies in the world came from increases in productivity, using technology, previous generations of technology, the complementary management innovations that came along with those technologies. What's going to happen to labor force growth in the next 50 years in many of the biggest economies in the world? Yeah, the growth rate will decline. Actually, the growth rate in many of these economies will be negative. Which direction is the population and workforce growth rate in Japan today? What's the sign? It's negative. What will it be in China within a decade? The largest country in the world will have a negative growth rate in terms of the number of people. And so basically half of the sources of our economic growth in the largest economies in the world is about to fall off the table. And so, of course, at least we can continue to increase our productivity growth. What's happened to the productivity growth in the US in the past 3 quarters? Flat, or for a couple of quarters, it was actually negative as well. And so this is scary stuff, people. I mean, the election's scary too, but this is scary as well. Because that basically means our kids are not going to have as good lives as we do. And that's a scary world. So we worry about AI taking people's jobs. We might start to think about, can AI be the thing that saves the economy by increasing our productivity so that, in fact, we can continue to have economic growth? And so that's a little bit of the case that I'm going to try to make today. By the way, I don't know if the answer is yes yet, right? We're still doing the research. All right. Anybody recognize this guy? Yeah, Sundar Pichai, right? CEO of Google, not to be confused with Alphabet. What did he say at Google I/O? He basically said, we're embedding AI in all of our services and products, right? Lots of companies said they're going to be mobile first. Now lots of companies are starting to say they're going to be AI first, right? And so that's changing the game. What did we do to try to understand the potential impact of AI when it comes to automating human tasks, right, or human activities? And again, that's not the only application, right? This panel talked about a lot of different ways in which AI could be applied. And by the way, we're going to talk broadly about AI and robotics here, so all types of automation. We looked at not only every occupation in the economy, but every constituent activity within every occupation, because we think the level of granularity of analyzing just occupations is not the right one. Because we think it's very rare that you could take a person out of their role and completely replace everything that they do with a robot or an AI algorithm or a system such as that. It's quite rare. Actually, when we studied it, less than 5% of entire occupations could be automated by adapting currently demonstrated technologies. For each of those activities, we understood against 18 different capabilities which potentially could be automated, the degree to which that capability was necessary. So a bunch of those things were physical types of activities, fine motor skills, navigating the physical world, gross motor skills. Some of them were sensory, so being able to recognize objects, being able to hear things, being able to understand human natural language, being able to produce natural language, a bunch of cognitive tasks, and even a bunch of emotional and social tasks. And compared those against the currently demonstrated technologies that we've seen in defense laboratories, that we've seen in corporate labs, that we've seen in academic institutions, that we've seen in actual products being released, whether they're RPA, et cetera. And so I want to just, again, stimulate conversation by showing some examples. Does anyone know who this person is? Yes, it's Radha Prabhakar. What's her job? Yeah, she's the head of the U.S. Defense Advanced Research Projects Agency, which lots of people know. I mean, SRI does lots of great research. DARPA does lots of great research. People remember, for instance, they funded the development of the internet, et cetera, with help from some other guy who ran for president once. Okay, old joke. Anyway, so what's an interesting thing that DARPA does in order to fund new research, right? They've started using contests, which is a different way of doing defense contracting rather than writing out a spec and then issuing the RFP and then awarding that to the best and most responsive defense contractor bidder. They put up a contest. So people know, for instance, self-driving cars, put $1 million up for the first car that drove, I think, about 200 kilometers through the California desert. Who won that one? Stanford? No. Well, I'm a Stanford fan, but unfortunately, no. Carnegie Mellon? No. Microsoft? No. Trick question. Actually, nobody finished, right? It was a total disaster in 2004, the first time they did it. Of course, within 10 years, you go out there today, right? You might see an Uber self-driving car, right? And even though nobody finished it, they got way more than $1 million of effort, right? Which is a very efficient way of doing defense contracting, right? Forget about the $900 toilet seats. This is a powerful way. Run contests. So they've actually been doing a lot of stuff in AI, and they've been doing a lot of stuff in robotics. So last year, actually earlier, last year, they had a robotics grand challenge. And I think they put about $3.5 million up in the prize for a bipedal robot to go through an obstacle course on basically a rescue mission. Because as you can imagine, there are lots of times when you have an injured soldier and you need to go rescue them. So if I can make this work, my friend back there will help me show some of the results of this contest. So I don't know why robots have so much trouble around doors. Now, this is actually hard, right? I mean, you've got an uneven pavement. You also have these different types of surfaces, again, with the doors. Not sure why. They actually had to leave a vehicle, and that's a tough one. Watch this person in the background who realizes, ooh, something fell behind me. Stairs are hard, right? We all know sometimes the stairs are hard for us. And then these projects actually, Hector, come on, Hector, come on. Oh. No, they actually had to do some use tools as well. So one of the tasks is to grab that valve. This one thinks it has the valve, and it's going to give it a really good tug. Yeah! Oh, it's tough. Doors again. No. I got to grab this. Oh, no, come on. Come on, grab it. That's hard. And then this guy I feel most sorry for. Come on. Come on. Get out of there. Get out. Get out. You can do it. Oh, it's terrible. Okay, you might say, look, disaster, right? But you would have said the same thing about the self-driving car contest in 2004. What's different about this contest? 4 of those robots finished. And in fact, so they had to have a tiebreaker. The tiebreaker was the one who went through the course the fastest. Of course, the unfortunate fact about that, the programmers of that robot, decided to take a victory lap and wave, and then it fell over. But anyway, things are moving along, right? So that's in the category of physical activities. Who's this guy? He already came up to me today. He didn't show up here, but he was mentioned today. Yes, Gary Kasparov, right? By the way, he had a great tweet today. He said, if you're nervous about the election today, sorry, I'm a little obsessed. If you're nervous about the election today, that's the feeling of democracy. Which is kind of cool to think about it, right? Anyway, why else is he famous for being, the best chess grandmaster in the world? He was beaten almost 20 years ago, right, by some IBM machine. And this guy, again, who also showed up today in our conversation. Anyone? Who is it? Lee Sedol, right? Famous for the world champion in Go. Of course, he was beaten earlier this year, despite the fact that people said machine wouldn't beat the best Go player for another decade or so. So, surprise, but who cares, right? These are board games, right? But it is an example of what we think is the automation of increasingly knowledge work. Because if you think about robots, it's easy to dismiss as low-wage, low-skill labor, but then you start to think about what do we pay MBAs to do? Who wrote this report based on a business intelligence output? Yeah, come on, it's some sort of algorithm, right? Right? This one was from narrative science. But again, we're paying people with graduate degrees to do this work, and it is starting to become automated as well. Does anyone know who this is? Her name is Rana El-Kaloubi. She is a former student at the MIT Media Lab. At the Media Lab, she studied how to help people who have autism. So what's the condition of autism? It's the inability to recognize human emotions in other people. And if people have seen this TV show called Lie to Me, it's based on work by a psychologist across the bay named Paul Ekman, who has this theory that there's a universal set of human emotions that are expressed in one's face, right? And so he taught people how to detect lies by micro-expressions, just staring at people, and teaches police investigators and others how to do that. She basically used that theory in order to figure out how to teach computers how to recognize human emotion. And she was using that when she was a student in order to help people who have autism. Now it's being used for, right? I mean, if you do marketing and there's a Q meter that says how much do you like this commercial, et cetera. Now the Q meter can be replaced by, the little camera on your laptop, and you can have this type of stuff go out across far more people than you would normally pay people to watch commercials. So commercializing this type of technology means that not only can you start to automate physical tasks, cognitive tasks, but increasingly emotional tasks as well. So then if you look across the entire economy, and you look at all these activities, not just occupations, there are three categories of occupations which we find to be more automatable than others by adapting currently demonstrated technologies. One of them is physical activities in predictable environments. You'll note that those robots that we laughed at were in relatively unpredictable environments. In predictable environments, highly automatable. But then a set of tasks which are about a third of the activities that we do in the economy now, which are collecting data and analyzing data. Again, we are paying high-wage, high-skilled people to do this, as well as low-wage, low-skilled people. The other four categories aren't as automatable yet, but are headed in that direction. So again, if you look across all of the occupations in the economy, there is some negative correlation between wage rate and automatability. That being said, there's a significant percentage of almost everyone's occupation which could be automated by adapting currently demonstrated technologies. Our estimate for CXOs is in the 20 to 30% range, which most CXOs eventually, when they think about it, say, please give me that time back. So, by the way, if you want to play around with it, we've put this visualization on online, and you can go and find your own occupation or those of your close friends to figure out how automatable they are. Let me finish. This is research that we're currently in the process of trying to do. Because as we looked across all of those activities, roughly 45% of the activities that we across the entire economy are automatable by adapting currently demonstrated technologies. Over 60% of occupations have over 30% of their activities that can be automated. But that's not going to happen tomorrow. How long will it take? Well, the quick answer is we don't know. But we do know that it's going to take some time. Because it takes some time to integrate different capabilities and then customize them for individual use cases. That's a lot of the work that many of you are doing here. Beyond that, it takes a significant percentage of time, or not percentage, it's significant time in order for adoption to occur. Right? And we've seen this in technology after technology, and literally it takes sometimes decades, oftentimes, usually takes decades, between the introduction of something that's commercially viable and its eventual plateau on the S-curve. And so we're starting to model that out across over 50 different countries, over 80% of the world's labor force. I will point out the following, though, here, that the error bars are huge. They are measured in decades, right? So we're pretty humble about this. We're not going to be able to tell you exactly what year something's going to happen. That being said, our point of view is basically this could happen quickly in micro. So if you are the truck driver who works for a large company that decides, look, we are willing to put the CapEx into a self-driving truck, that could happen very quickly for you. But it could happen more slowly in a macro level when it comes to the entire economy. So there's time for us to adapt as we adopt. So it's not going to happen tomorrow. It might happen tomorrow for you, but it won't happen tomorrow for the country. So we need to think about it. Let me finish with just one more video that can show what might happen if we're not very nice to these things. So this is a robot operating in an unpredictable environment, namely Boston. These guys, they're kind of mean with their hockey sticks. So it's meant to pick up this 10-pound weight and move it around. Well, he's not being very helpful about this, clearly. But the robot's adapting, so good research, good work being done. This is Boston Robotics, so apologies for the commercial there. It's for sale, by the way, if you want to buy it, reportedly. So it's going to chase this down. But this guy gets even meaner in a moment here. Just moving the 10-pound weight is no biggie compared to what he's about to do. No, come on, don't do this. Oh, and now it gets scary. If you heard the sound, it'd be even scarier. You think it's going to turn around? Thank goodness, no. It's just going to leave the building. All right, that's the end. We have like a minute for questions because we do want to make sure that you can get out to your coffee break and talk to each other, meet the people you shook hands with early in the morning. Otherwise? All right, one question. Yes?
What does AI do with the demand problem? Like with Caterpillar, they have plenty of equipment, they just don't have enough place to sell it to. So where does AI fit in that?
Yeah, where does AI fit in terms of creating demand? Lots of issues in the economy around potentially lack of aggregate demand. It potentially could create new products that so this idea that there are products that we don't know that we need or we don't know that we want because they haven't been created yet, AI perhaps could create some of those. But I think, broadly speaking, the connection is not super obvious. There's not an obvious way in which AI affects aggregate demand in ways that other technologies might not. Yeah. Real quick.
Can you just put up that URL again?
Oh, yeah, sure. There you go. All right. It's coffee break time. Thank you.